Dear students, I have come up with JEE Mains question paper, which was held on March 17th, 2021, under Part B Chemistry. So I would like to discuss the questions given under multiple choice questions. So out of 4 options, we have to select only one option, correct option we have to pick out. Here I'm starting with the first question. Reducing smoke is a mixture of smoke, fog, CH2, double bond, CH, so CHO, smoke, fog, and ozone, and smoke, fog, N2O3, and smoke, fog, SO2. So here, if you look for options, if you look, and the D option, smoke, fog, and SO2. SO2, in this SO2, sulfur oxidation state is +4, and so when it undergo oxidation, further oxidation, oxidation state can be changed to +6. So that means sulfur has ability to lose electrons. So how many electrons it can lose? 2 electrons. That means it can reduce other substance. So whereas this ozone and N2O3 and in this enolate ion, or what we call the CH2 double bond CHO, this is what we call this compound, enolate ion or carbanion. So this means oxidizing properties they have, but D has reducing properties. That means here the sulfur oxidation state in SO2 changes from +4 to +6 oxidation state, giving 2 electrons, causes reduction of other substance. That is the reason. We can do this answer for this question. And now the second question is, we should go for the D option here. And which of the following compound cannot act as a Lewis base? So options ClF3, B PCl5, NF3, and SF4. Now let us look for the options. So ClF3, the chlorine will make 3 with the fluorine, 3 covalent bonds it can make. As you know, the chlorine valence electrons are 7. Out of 7, how many used? So 3 are used, and 2 lone pair electrons are left behind. So which of the following cannot act as a Lewis base? So Lewis base, since it containing 2 lone pair electrons, it has, so act as a Lewis base we can consider, because 2 lone pair, it has ready to donate 2 lone pair of electrons. And if you take PCl5 compound, in this PCl5 compound, phosphorus will make pentavalent. So the valency of phosphorus, 5 electrons, completely used. No more lone pairs, no lone pair electrons, no lone pair electron. It cannot be Lewis base. It is not Lewis base, we can say. And NF3, nitrogen make 3 bonds with the fluorine. 3 bonds can make fluorine. There is 1 lone pair is present. It is Lewis base it can form. And whereas SF4, the sulfur will make 4 covalent bonds with the fluorine. So 4 covalent bonds with the fluorine. There is how many sulfur valence electrons are 6. Out of 6, 4 electrons are used. 1 lone pair is present. It also acts like a Lewis base. So out of 4 options, the correct one B. So PCl5 is the correct option we can give. Now question number 3. If you read the question number 3. Now let us discuss question number 3. Given below are two statements. So this is a statement-based question. Two statements are given here. One statement is potassium permanganate KMnO4 potassium permanganate. So on heating, so how much temperature? 573 Kelvin temperature forms potassium manganate K2MnO4 plus MnO2 plus oxygen. This is the reaction at 573 Kelvin temperature. This is potassium permanganate changing into potassium manganate. All right. Statement 2. Both potassium permanganate and potassium manganate are tetrahedral and are paramagnetic in nature. So here is manganate, so permanganate and manganate. So if you look the structure of this, so tetrahedral, okay, but we should check that magnetic nature of this. So in KMnO4, we should look oxidation state of manganese is +7. So whereas in K2MnO4, oxidation state of manganese is +6, right? So manganese, so +7 oxidation state, manganese +6 oxidation state. That means here if you write 3D configuration, 3D 0 and 4s 0, it would be, and 3D 1 and 4s 0, that where d orbital having, so one unpaired electron is present, and 3D 0 no electron is present in this. With this, what we can understand, so for the paramagnetism, one means unpaired electron is required. Unpaired electron is needed. Unpaired electron required for the paramagnetism. That means K2Mn4 is paramagnetic and KMnO4, so no unpaired electron in this, so it is diamagnetic nature. So diamagnetic nature, KMnO4 is diamagnetic nature. 2. So potassium manganate is paramagnetic nature we can say. So with this, now the first option is potassium manganate is right, and both potassium permanganate and the potassium manganate are tetrahedral and paramagnetic. So the statement is wrong. Then the third answer, so third answer is first one is correct statement is true, and the second statement is false. The third option is I'm going for A. A option is correct one. Now the question number 4 is given here. Question number 4, and so look at the question number 4 here. This is chlorobenzene. This is chlorobenzene is given. The chlorobenzene is given, and the chlorobenzene treated with this sodium hydroxide. Sodium hydroxide gives rise to form sodium phenoxide. So this is the sodium phenoxide is formed. So above reaction requires which of the following reaction conditions? One is given 573 Kelvin, 300 atmospheres. B is given 623 Kelvin copper and so 300 atm. 573 K copper, 300 atm, and D option is 623 Kelvin, so 300 atm. Since here, so two options copper is given, copper catalyst based. This is not catalyst based reaction. So eliminate the two options, C and B. So we can eliminate because it is not catalyst based reaction. This is particularly copper is not used in this reaction. So we can eliminate two options here. Now the two options A and D options are left. So here is low temperature here, and here is high temperature is used. That means we'll go for the high temperature because what is the reason means here on the aromatic ring there is halogen is present. So here is nucleophile, NaOH consisting of the nucleophile. The nucleophile so cannot displace the halogen under nucleophile which is attached to sp2 carbon aromatic ring. Quite difficult this is. It is quite difficult process to, that means what we call this nucleophilic substitution reaction. So aromatic halides do not undergo nucleophilic substitution reactions. It is quite difficult. So that's why we need to raise the temperature to 623 Kelvin, 300 atmospheres pressure we have to use such that to make this reaction possible and to get the phenol, product. So then D option is right because at high temperature the chlorobenzene undergo nucleophilic substitution reactions. Not at low temperature is not possible. At the low temperature is not possible. So because the halogen is attached to sp2 carbon, where sp2 carbon is so more electronegative. Okay, and so this is the answer for this fourth question. And fifth question, let us a central atom in a molecule has two lone pair of electrons and forms three single bonds. The shape of the molecule is a central atom in a molecule has two lone pair of electrons. So Xc is the central atom having two lone pair of electrons. Two lone pair of electrons it has and forms three single covalent bonds it will make. The shape of the molecule is trigonal pyramidal shape, planar triangle, T-shaped, and seesaw shape. Here is three options: trigonal, pyramidal shape. That means here trigonal pyramidal shape. So trigonal pyramidal shape. This is the shape we can get. Trigonal pyramidal shape we can write, or we can write like this. This is trigonal pyramidal shape. Next one is a planar triangle. So simple planar triangle we say. This is planar triangle. So no lone pairs for this. And T-shape. So T-shape is a molecule, three covalent bonds. Here lone pair. So lone pair causes repulsion. Then so we can go for this T-shape because two lone pair of electrons present on the central atom, and seesaw. So not with this two lone pairs. So only the C option we can go. Fifth answer is C. We can write. Now another question. So we discuss another question. Give Given below are two statements. Statement 1, retardation factor RF can be measured in meters and centimeters. And the statement 2, RF value of compound remains constant in all the solvents. Choose the most appropriate answer from the options given below. Statement 1 is true, but statement 2 is false. So meters, measuring meters, so which is not appropriate. So it is a false, we can write. And other one is RF value of compound remain constant in all the solvents. No, not. It differ from the solvent to solvent. So that's why the both statements, statement 1 and statement 2 are false. We can go. And the sixth question will be, so B is the correct answer. We can go. The question is, question number, mesitile oxide is a common name of, so common name of 2,4 dimethyl pentane 3-one. B, 3-methyl cyclohexane carbaldehyde. And C is 2-methyl cyclohexanone and 4-methyl pent-3-ene 2-one. So mesitile oxide is a common name of. Actually, the mesitile oxide is the compound which is found by self-aldol condensation. Self-aldol condensation of ketone. The ketone example is CH3, C. So acetone means we can write propanone. Now let us look into this. When the propanone, two molecules of propanone subjected to hydrolysis in the presence of sodium hydroxide, so we get the compound is mesitile oxide. The mesitile oxide, the formula is CH3 CO CH3 CH3. Here is a double bond here. Sorry, here let me write. The CH3 CH double bond CH4. So here this is the compound which we call mesitile oxide. This is the compound we can get. Let us look into this, how this compound is formed. Now, self-aldol condensation. The nucleophile of this sodium hydroxide remove the alpha hydrogen from this. One acetone molecule. This proton is removed by this. Then the sigma bond turn into double bond here. So then it can result CH2 carbanion of ketone is formed here. The carbanion of ketone attack another molecule of acetone. Look at this. Now this negative charge attack this electrophilicity of the carbon, where this pi bond undergo resonance onto the oxygen. Then the resultant structure will be CH3 CO minus and CH3. Here is CH2 CH3. So this is the structure. Now carbanion attached to the electrophilicity of the carbon and followed by hydrolysis. So we can get CH3 COH and CH3 CH C double bond O CH3. Now, upon heating this, so this water molecule closes water molecule, and here double bond is formed. Here double bond is formed. You can see this structure. So this is the mesitile oxide. So now here is the option is you can go for that option. The IUPAC name of this compound is here. So what is the IUPAC name of this compound? 1, 2, 3, 4, 5. So pentane 1, 2, 3. So 3 in pent 3 in 4 methyl is there. Pent 3 in 2 one. So here the D option is correct one. So based on the self aldol condensation or simple aldol condensation, we call this one. Simple aldol condensation of ketones will give this product. D product is the right answer. D is the right answer. Now let us move to the question number 8. Question number 8. The absolute value of electron gain enthalpy of halogen satisfies. Absolute value of electron gain enthalpy of halogen satisfies. You can see fluorine greater than chlorine, bromine, iodine. Chlorine is greater than fluorine, bromine. Here answer is B option, because the reason is the size of the chlorine atom is bigger than the fluorine. The fluorine is a small atom. So what is electron gain enthalpy? When electron is added to the chlorine, when electron is added to the fluorine. So when so atomic number is 17, atomic number is fluorine is 9. When the electron is added to the fluorine, what happens? So means incoming electron experiences less repulsion because of large size. And whereas in the because of fluorine atomic size is very small atomic size, incoming electron experiences more repulsion, then we need to apply some energy. So the enthalpy change is less negative. Enthalpy change after addition of this electron, the chlorine is more negative. Delta H value is more negative, here is less negative. Almost all how much? Minus 348 joules per mole, and it is 328 minus joules per mole, we say. That means here is the B option is right. So other options not relevant. A colloidal system consisting of gas dispersed in a solid is called a gel, liquid solid, aerosol, so liquid in gas, solid, solid, foam is the right option. Foam, rubber, and we can give the pumice stone example, foam, rubber. Example we can give. So now 10th question. The incorrect statements about heavy water are used as a moderator in nuclear reactor, right? Obtained by byproduct of fertilizer industry, right? Used for the study of reaction mechanism is right, deuterium oxide. So higher dielectric constant than the water. It is wrong, because the water dielectric constant is 80, whereas deuterium is 60. So that means for water is more and deuterium is, so here is higher dielectric constant. This is the wrong option, but correct means incorrect statement is D. So rest of the 3 statements are correct, we say. That means so D only answer. A is a correct option we can give. Now the 11th question, let us look into the 11th question. Now, the 11th question, we will look into that. Question is, so what is the question is given here? Here is the question is given. The cyclohexane attached to methyl group and unsaturated branch it has. So it is subjected to HBr, treating with HBr in the presence of carbon tetrachloride. HBr in the presence of carbon tetrachloride, so undergoes addition reaction. It would be addition reaction because HBr, so hydrogenation of CCl4, carbon tetrachloride. The major product is, what is the major product? So A option, you can observe where the bromine is attached, and the B option you can see, so where the bromine is attached, and the C option the bromine attached, and so now we'll get the answer. Look at this. Now here is for the cyclohexane. Here is there is double bond, and here is the methyl group is present. Methyl group is present. Now, when HBr is added, so the protonation is done for this H plus. So when the protonation is done here, there is a positive charge. Carbocation is formed here. So when the carbocation is formed due to the protonation to the proton, the Br, possibility of attacking the Br. So here is 2-degree carbon, and here is the 3-degree carbon is there. Here, this addition reaction will go based on rearrangement process. Rearrangement. So what is the rearrangement here? There is a rearrangement through methyl shift. Methyl shift takes place here. What is the methyl shift? The methyl group will migrate to this. Then on the, now see, here is the methyl group. Here I am adding the positive charge here. Now it is the most stable carbocation is formed. This is more stable carbocation is formed. The most stable carbocation. Next, the Br is the nucleophile. So chances of attacking at this carbocation will form the, now here is the Br is attached, here is the methyl group, here is the methyl group. So now here is D option is right. This is the most stable product here, and here one more product also possible here. Now here is the Br possibility, and here is the methyl possibility. This is less percentage, this is less stable, this is more stable. So D is the correct option in this case. Now 12th question, let us look into the 12th question. Which of the following is correct structure of tyrosine? So tyrosine is type of amino acid. Amino acid we say. So which type of alpha amino acid we can call? So here is functional group carboxylic acid, NH2 is there. Both are connected to alpha carbon here. Now here is alpha carbon. sorry, this alpha carbon, but here is alpha, beta, gamma. So this is wrong because uh, phenyl ring should be connected to alpha carbon. Here is alpha carbon, but OH group is present on the meta position. This is also wrong. And here you can see OH group para position, and phenyl ring is connected to so alpha carbon here means this is carboxylic group and NH2 connected to alpha carbon. The carboxylic group and NH2 group connected to alpha carbon, then it is what we call means tyrosine. So phenyl alanine we say this is. So this is C is the correct option. We can go. The tyrosine is important for the protein synthesis. So now the 13th question, if you look for the 13th question, Hofmann bromide. So in the previous class also I was talking about Hofmann bromide reaction, which is a very important reaction. Hofmann's bromide degradation of benzamide gives the product A, and which upon heating with CHCl3 NaOH gives product B. So generally Hofmann bromide reaction is seen in the amides. So here is mentioned CONH2 benzamide. So this is called benzamide gives product. Generally when benzamide undergoes Hofmann bromide reaction, it can be the compound we get primary amine. That means 1 degree amine we can get. Primary amine we can get. Primary amine aniline we can get. So which upon heating with this CH3, this compound upon heating CHCl3, so chloroform in the presence of NaOH, sodium hydroxide. So what we can get, the B product we can get, B product. So in the presence of chloroform and sodium hydroxide, the reaction is phenyl isocyanate. Mic gas we can get, which is obnoxious and foul smell. It will give foul smell and dangerous. So mic gas we can call methyl. Sorry, it is similar to methyl isocyanate, but it is a phenyl isocyanate. PIC. This is mic is methyl isocyanate CH3NC. So which is very dangerous. Very dangerous. Smell is very dangerous. So phenyl isocyanide is also dangerous. So this is the structure we can get. So here options, what options are there? Aniline is right, isocyanide is right. A is the right answer we can give. Now the question number 14. The question number 14. We'll discuss question number 14 from this paper. The question is given on correct order of conductivity of ions in water. The conductivity of ions, so based on what reasons? So here based on the size factor we should consider, and easy to mobile, easy to move, and based on hydration enthalpy, based on hydration of ions we say, and also charge produced over the ion, charge over the ion. So these are the reasons we can say. So now here is the correct order of conductivity of ions in water. We can take here is so first option, second option. We can go for the B option, because what is the reason means? So the reason conductivity depends upon. For example, if you take the lithium ion is very small, and its charge density is more. Charge density is more. The charge density is more, then hydration properties are more. So lithium ion gather more water molecule, then size increases. Size increase because of its high hydration property. Hydration property. So its size increases, unable to move, we say. Whereas the cesium hydration enthalpy is less, so gathering because of its more size, it cannot accumulate water molecules more. So here we can take this example, means B is the correct option for this. B is the correct option. That means, so hydration property of lithium is greater than sodium, sodium is greater than potassium, potassium ion is greater than rubidium, rubidium is greater than cesium, we say. So hydration means, so lithium gather more water molecules, then size increases, unable to move, and sodium so also gather more water molecules than potassium, rubidium. So hydration property for the cesium is less. Then B answer is most appropriate one. 15th question, what is the spin only magnetic moment value Bm of divalent metal ion with atomic number 25? So atomic number 25, what is that atom is manganese. Divalent means Mn plus 2. Mn plus 2 configuration is 3D. So Mn 3D 4s0 this is. So that means there are how many unpaired electrons are present in d orbital? 5 unpaired electrons are present. What is the formula? Here is Bohr magneton Bm. So Bohr magneton formula equal root 2 into, so 2 n into n plus 2. So here is the formula, n value 5 plus 2, how much we can get? So 7 5 into 7, 35, root 35. So the root 35 value 5.92 around will get answer. So 5.92 is the correct one. So again, I'm repeating this question here. So what is the question is given? What is the spin only magnetic moment value? So Bm of divalent metal. Divalent means Mn plus 2 ion here. So its atomic number is 25. So Mn plus 2 means, so 3D 5 4s2 4s0. So for a zero configuration, that means there are how many unpaired electrons are present? 5 unpaired electrons are present. So for the magnetic moment, so Bm is equal to Bohr magneton equal to 2 root under root. So sorry, n into n plus 2 formula we can use. And where n value, n is equal to 5 unpaired electrons, 5 into 5 plus 2. So we can get so 5 into 7, so 35, root 35 equal to 5.92. So answer. So now let us move to 17th question. Here is the what is the, so here is the two functional groups are present. One is ester and other one is ketone. And ethylene glycol means alcohol, means ethylene glycol is diol. This is, so ethylene glycol is diol, we can write. So it is when for the ketone, that means here one ketone functional group is there, and that means alcohol is added, means that when ethylene glycol is added in the presence of acidic medium, so then it is so ketal formation, we say ketal formation we can write. So how the ketal formation is a nucleophilic addition we can write. So here when the alcohol group approaches to this, so here is the electrophilicity carbon, here is the negative charge. So here one OH will be added, means water molecule is eliminated from this. So the most electronegative added to this carbon positive charge, and most positive charge will be added to this oxygen. Then we can get cyclic formation here. So the C option is right. The C option is right in this question. That means here we can add, this is ester functional group C2H5. Ester is not disturbed by that. Here is the O minus and here is the positive charge. Now, so we can add, here is O of CH2, and here will be the positive, and the negative will be positive. CH2 group is added here. So cyclic form. Okay, right. Now the 18th question is, which of the following reaction is example of ammonolysis, means addition of ammonia. So ammonia, so means here is cyanide, so reduction, okay, but in this there is no ammonolysis, and in this, so chlorine and NH2, so we can get COMID is formed here. This is not ammonolysis. And C6H5NH2 HCl, and we got this. So this is also not appropriate one. This is halide plus ammonia. So here this is the right option. We can say as NH3 loses one hydrogen, it becomes NH2 minus, and the chlorine combined with this, hydrogen will form. So here is C6H5 CH2Cl plus NH2H. So the chlorine and hydrogen both will combine. This negative group nucleophile attack this positive carbon. As a result of this, we can get C6H5 CH2 NH2 is formed. This is ammonolysis. Ammonolysis process we can write. Now 19th question. So here is the 19th question. The point of intersection and the sudden increase in the slope in the diagram given below respectively indicate. So delta G equal to 0, reduction of the metal oxide. Delta G is equal to 0, melting and boiling point of the metal oxide. And delta G is greater than 0, decomposition of the metal oxide. Delta G is less than 0, decomposition of the metal oxide. So here is when this is aluminum diagram, we say here is delta G is shown here, and here is temperature. Now, for example, here is the A point is the intersection point. So at this point, the delta G becomes 0. Delta G so will become 0. That means here delta G is 0, melting and boiling point of the metal oxide. That means suddenly here the metal oxide from solid state changes into liquid or even vapor. So delta G equal to 0. This is that melting and boiling point of the metal oxide. B is the appropriate one. Now let us look into this 20th question here. 20th question, which of the following is an aromatic compound? In the earlier class also we were discussing about aromaticity. So for aromaticity, so what I was telling conditions, molecule must be planar. Number 2, it should undergo sp2 hybridization and complete delocalization of electrons it should have. The fourth one is 4n plus 2 pi electrons rule. It should follow 4n plus 2 pi electron system it should obey. These are the conditions. Now, first one, obeying 6 pi electrons, it can follow. So there is a complete delocalization.